En dan gaan wij door naar onze volgende spreker en daarvoor, of onze volgende gast. En daarvoor gaan we schakelen naar het Engels. We will be switching to English because he will be looking at the business case from an investor's perspective. I'm talking about Adam Ben-Hamo. He's a senior analyst at Asper Investment Management. And that's an independent UK-based firm focusing on building sustainable real assets. And Adam will talk us through the business case of the 5th generation district heating and cooling. And he will do so in English, obviously. So I'm just checking if Adam is already there.
I am here. Can you hear me?
You are there. I can hear you somewhere, so I hope everybody can hear you. Adam, about 15 minutes for you to talk about the business case. Go ahead.
Fantastic, and thank you very much for the introduction. Are you able to see my slides?
We'll put your slides up, of course.
I'm just sharing my screen now, so hopefully they're visible.
I see some slides.
Fantastic.
Okay, go ahead.
Great, so I'll crack on. Hello, everyone, and it's a pleasure.
Oh, one thing, sorry, maybe, Adam, can you talk a little bit louder in your microphone?
Yeah, of course, I'll try and speak directly.
Yes, that's better. Thank you very much. Great.
Fantastic. Well, hi, everyone, and it's a pleasure to be here with you all today. We're very thrilled to see such a large and diverse group of people here interested in 5th generation district heating and cooling. For the purposes of today's demonstration, I will say 5G, just to keep things nice and quick. So as the introduction was, my name is Adam and I work for Asper Investment Management. We are an investor into sustainable real assets, including renewable power, so wind, solar and hydro, and more importantly for today, renewable heat in the form of district heating networks. So we currently manage about 1.3 billion euros worth of capital, and some of that to date has been invested into district heating already, some in Sweden and a portion more recently in the Netherlands. Now, we've got involved in 5G district heating through the Interreg D2 Grids project, which is a European publicly funded project with the aim of commercializing 5G across Northwestern Europe. And as you'll see from this presentation today, 5G district heating and cooling is a topic that we at Asper find very, very interesting indeed. So just a quick introduction into and some background into what it is that we're doing in the Netherlands. So earlier this year, we set up a brand new fund backed by several well-known institutions, including APG and the EIB, and with the simple goal of building large portfolios of city-wide sustainable district heating networks. So we acquired an existing business in Ede and partnered with a local developer, also based in Ede, to build out a much larger pipeline of projects across the whole country, currently looking at over 20 different areas. Our projects will use a range of 3G to 5G technology, and we're trying to include more and more 5G concepts as time goes on. And we intend to use a wide mix of sustainable heat sources, adapting to the best use case that we find in each particular city. So why are we interested in 5G? And I've put a little bit of a summary here, just so you get the high level idea. But actually, 5G has a lot of traits that are very similar to conventional 3rd generation or 4th generation district heating. So it is a core asset that generates long-term stable cash flows that aren't linked to wider economies, that aren't linked to stock markets, but that are consistent over time. Not all conventional networks are sustainable, but many of them can be. And so that trait is also shared perhaps with conventional networks. However, the true 5G concept only has one option. It has to be green. Now, unlike conventional district heating, 5G offers new opportunities both to manage risk and to grow projects into larger, more profitable projects over time. And we've called these de-risked and future-proof. And over the course of this presentation, I'll explain in a little bit more detail exactly what I mean by those two terms. But before we go on to that, I want to talk a little bit about customer value. So customer value, as you can imagine, is critical to the business case of any new technology. If it is cheaper to provide heat to the customer using a new option, then that option is likely to succeed. If it is much more expensive, it is very difficult to see the large-scale rollout of new technologies. So the chart I'm showing you here is perhaps the most important chart in my presentation today. And what you can see is the levelized cost of 4 different technologies for supplying sustainable heat to housing. So what we already know is that district heating is the cheapest option of all. ground source heat pumps and air source heat pumps, while they can be very suitable for very remote locations, are generally more expensive than centralized systems and district heating networks. Now, the other thing we see here is that 5G district heating is not quite as competitive as 3G is today. Now, the reason for that is there's quite a lot of processes required in order to standardize equipment, to standardize engineering and design, and to allow for the falling technology costs over time. And as a result, you can see that we are quite optimistic about where the cost of 5th generation will go over time. And you can see the error bars there on the orange bar showing a much lower number than any of the other competitors. And that's where we believe 5th generation district heating and cooling can go in future, and why we believe it can succeed as the dominant technology in decarbonizing heat and enabling the energy transition. So my next slide is just a quick summary of what we see as the core elements of the 5G district heating and cooling business case. I'll run through them quickly, and then over the next few slides, we'll go into a little bit more detail on each one and how it differs from conventional sources of heating. So first of all, investment. Now, of course, that's a very core part to any business case, and we'll see today how 5G networks have a much more stretched out and longer investment profiles, and how this benefits the risk-return elements of a project. Revenue, we'll see how contract structures can differ using 5th generation and how access to new types of revenues that conventional competitors can't access. We'll see how 5G district heating can allow suppliers and generators to minimize their costs and therefore pass that saving through to customers. And we'll see how growth opportunities for 5G are much greater than they are for 3G and are not constrained by centralized biomass gas boilers. Now, we'll also discuss in a little bit of detail other funding sources. Now, this varies a lot from different geographies, different local governments, and also different customers, but can make up quite a significant part of the investment case for any 5G network. So let's start there on investment. And the first kind of chart I want to draw your attention to is the difference in investment between a 3G and a 5G network. So if you look at my chart here on the right-hand side, you'll see the gray bars, which represent investment into conventional district heating, and the blue bars, which represent investment into 5th generation. Now, what you can see quite clearly is that for 3rd generation, there are very high upfront costs associated with new boilers, core network, large-scale energy production, whereas for 3G, you have much less upfront investment, but a much longer investment profile. Now, that is because instead of buying a big expensive boiler to put centrally in the city and distribute heat from there, your investments are actually into heat pumps located at customer locations and only made once that customer is connected. And that means that you have much greater visibility over when you make investments. Now, there are two outputs from this. You can see that the dotted lines show the build-up in total customers. And what's quite noticeable is that on the gray line for 3G, you have to have a much, much higher number of customers connected on day one. Now, that's because you've put a very large investment into the ground on day one, and you need to be sure that you're going to get a certain level of revenues to make your money back. With 5G, you're making much smaller investments on day one, and therefore you can begin to start your network with fewer customers and already having an operational and profitable site from the first year of operations. Now, the other point here is not just that it allows projects to be delivered more quickly, but also that it allows for projects to develop whilst the investor has good visibility on getting their money back. And that's crucial because by allowing investment to only occur when there is high visibility on revenues, you massively de-risk the level of risk in the project, and it becomes much more appetizing and attractive to investors.
Adam,
yep.
Marcel here, let me briefly interrupt you because the slides you are showing, or that we are showing, are not completely visible. The bottom part and the right part is not visible for the viewers at home, which is not a problem, but it's maybe good for you to know. We'll send, of course, the sheets to everybody. But yeah, well, this this helps. Yeah.
Is that a little bit better?
Yeah, it certainly is. Yeah. Yeah. Great. Thanks.
Great. So I'll continue on that basis, no problem. So I'll flick on to my next slide now. And this is to do with the revenues and the costs. Now, we'll start off on revenue and talk a little bit about how 5G makes its revenues differently to 3G. Now, there is a core income model that is similar to conventional networks and that is similar to gas heating in the house that everyone will be familiar with. And that is a fixed annual fee followed by a variable usage cost. So you pay a small amount upfront and then you pay variable costs every month depending on how much energy you use. Now, actually, 5G offers some somewhat different opportunities here. And the difference arises because when you are selling heat using a 5G network, you are also creating some cooling supply. And so as your customers have a larger and larger demand for heating, you have a greater and greater supply of cooling. And the same works in reverse. Now, that means that if you have your network correctly balanced, you can afford for any one of your customers to have a much higher heat demand in the knowledge that they will also be generating more cooling supply that you can then sell and make up any lost revenue. What that enables a 5G district heating operator or supplier to do is to actually charge customers on a fixed annual basis only, depending on the size of their connection, but not the actual usage. Now, what that allows for is a much more stable visibility over what your revenues will look like over the next 1, 2, 5, or 10 years. And again, that gives investors a lot more confidence to put money in upfront, knowing that their revenues are stable and secured in the long term. Now, another source of revenue, my point C here, is around flexibility services. And this arises from the fact that fifth generation networks incorporate a large element of storage into their design. Now, by incorporating storage, that gives operators the choice as to when exactly they want to pull heating into the system by operating heat pumps, and therefore the choice to reduce that amount in times where there is great load on the electric system. Now, in many countries, including the Netherlands, Ireland, and the UK, there are systems in place where the grid operator, that is the electrical grid operator, will pay people to either add or remove load at specific times in order to allow them to balance the grid system. And through these types of flexibility contracts, 5G heat pumps can therefore run selectively and only at times when they are kind of providing a service to the network operator and getting paid a revenue for that. Now, similarly, there are many benefits on the cost side of things. So the first is quite obvious, that 5G is a low temperature, low energy based system. And what that means is that you can leverage much cheaper sources of heat that are typically at a much lower temperature. So rather than having to burn gas or biomass to get your 90 to 100 degrees centigrade water, you can instead use waste heat from data centers, from CHP plants, from manufacturing that is available for free or sometimes very cheaply, allowing you to actually reduce the cost of your primary energy demand. Now, secondly, when you do have a primary energy demand, a large portion of that is actually derived by the use of heat pumps, which in turn are dependent on electricity markets. Now, electricity markets are more mature, more stable, and more liquid than commodities such as gas or biomass. And again, that allows investors to keep the costs low, but maintain a very high visibility of what future costs are going to be, which allows them to build more and more confidence in the investment case. Now, finally, I mentioned on the revenue side how flexibility and storage can be used to access new revenue streams. Simultaneously, it can also be used to ensure that energy is only pulled from the electricity system at a time when it is cheapest. So for example, if heat demand is highest during the evenings when people are at home, but actually power prices are cheapest late at night when everyone is asleep, then systems can be optimized to heat up the storage at nighttime when power is cheap to access and deliver that heat when it's needed in the evenings at times when power would otherwise be very expensive. And so through these mechanisms of flexibility, there are many ways to extract new revenues or reduce costs at fifth generation district heating projects that simply are not accessible to our conventional counterparts. So our next slide here is around growth and flexibility. So growth is naturally very important if you want to build large, profitable projects. 5G benefits with growth not linked to the capacity of a centralized boiler. So typically in a conventional network, you can only add so many customers before you need to build a big new boiler to heat up the water and so that you can add more customers to your network. With 5G, that is no longer the case. You can continue to add customers, adding local heat pumps as you connect them and make the network larger and larger and larger. all the while making sure that you maintain a level of balance between heating and cooling of the network overall. And that's quite a key point. It is very important that 5G networks are built in an area where there is a high heat demand, but also a sufficient cooling demand to balance that network. Otherwise, your aims of kind of recycling waste cooling and waste heat when the opposites are generated is very low. Now, the final point is that networks can combine to each other or connect to conventional systems. So what this actually means is that two fifth generation district heating networks that are operating in different neighboring cities can eventually connect up, meaning a greater balance of your cooling and your heating, a wider stretch over the load, and better averaging over your different customers. And again, that means you increase efficiencies and allow for costs to be reduced.
Adam?
Yes?
I've got some questions for you, so I would like to address them, but how far are you in your presentation?
So what I will do is I will skip through a couple of the quicker bits now so that we stay on track. And then should we keep questions at the end?
Yeah.
Perfect. So let me skip past other funding and we'll come back to that at the end. And similarly, financing projects is now my penultimate slide. And so I think the key here that I'm trying to get across to everyone is that there are many options that exist when you're trying to finance new projects. Now, people are quite familiar with debt and equity, but there are other sources of funding that projects can leverage to get themselves off the ground. And there are two sources that I wanted to pick out here. So the first one is grants and subsidies, and actually that's probably better covered by other speakers today, and so I won't take up your time by talking too much about that. But the next is customer contributions, and this is critical both to conventional networks, but also to 5G networks. Now, often, and particularly with larger customers, you will find that they are contemplating a connection to a 5G network as a replacement to an existing heat supply solution, usually an on-site gas boiler. Now, that means that they understand that there is an investment required, and their choices are between investing in a replacement gas boiler or investing in a sustainable connection to a 5G network. What that means is that actually customers are able to invest alongside the project owners by providing an upfront capital contribution that often actually makes up quite a significant part of the investment case and can be really critical to getting projects off the ground. And this can be more so the case when projects can demonstrate a sustainability benefit, and that allows clients to make the stronger case as for why their connection should be to this 5G network and not a replacement of the existing gas solution. Now, without going too much detail into debt and equity, people will be quite familiar that these are two sources of capital that projects can use and require in order to get built. Now, I think that the easiest thing that I can cover today is just to discuss what the criteria for each are. So typically debt is based on high visibility cash flows. So in order to get a bank to provide debt to a project, what you need from your project is very long-term contracted cash flows that the bank can look at and take great comfort that they will be able to get their money back. And so whilst debt is a great place to access cheap capital, it requires you to be able to prove that the long-term benefits of your project will continue to stay and you'll be able to pay off that debt in the long term. Now, equity, on the other hand, is a little bit more expensive form of capital, but is able to take a lot more risk. So Asper is an equity investor, and that's what we typically would look at. And the way we think about equity investments is that you take on a lot more risk that projects won't grow to scale. But if projects do grow and they actually find that the cash flows are exceeding forecasts, then your potential to earn a return on those projects is much greater. And so good projects make a high return for equity, bad projects make a lower return, but debt gets a consistent return across projects. And that general framework is quite a useful way to understand actually, is my project capable of having debt on it, or do I need to fund it purely with equity, subsidies, grants, and customer contributions? Now, I realize I flicked through that one a little bit quickly, and so if there are any questions, I think we can follow up on the end. And there was just one last slide I wanted to talk about, which is how we as Asper can help. So just to be very clear, we are always open to new ideas, new projects, to meeting new people and to having interesting discussions. So please do reach out to us. We are currently, as part of the D2 Grids partnership, developing a financial model which helps to actually understand the risk-return characteristics of 5G projects. And we'd always be happy to have a quick introductory session as to how that model works and how people can use it. And then finally, I would always turn people towards the D2 Grids partnership, which is a very wide and very capable partnership of people who are developing a huge range of resources on technology, on financing, and on project delivery, all of which will be publicly available. And so I would urge you to look D2 Grids up and look at the resources that we have available there.
Okay, thank you, Adam.